Can light ever get tired the way we do? In the energy filament theory, the rhythm of light does not wear out on its own. What really fades is its separate identity as one clean, recognizable strand in the energy sea. Mainstream physics already says something close. That photons are not little runners that slow down from exhaustion. They only disappear when they are absorbed, scattered, or redshifted. But in this picture we can say more precisely why the tired light intuition feels wrong and why the universe still looks old. First, the relay mechanism itself does not fatigue. Imagine a line of people stretching around an entire planet. The last person in the line taps the shoulder of the next. That person taps the next, and the simple tap once, then relax action travels all the way to the front. No single person has to walk the whole distance. Nobody has to keep their arms raised forever. As long as each person just performs the motion once and passes it on, the tap can propagate through a billion people without any one of them getting worn out by the length of the line. In this picture, light is exactly that kind of shoulder tap. A small patch of the energy sea performs a little tightening release move, hands the pattern to the neighboring patch, then returns to its baseline. The neighbor does the same, then the next, and the next. As long as the local rules for how to move and who to pass it to stays intact, the relay can keep going without the sea itself becoming sleepy or diluted. The pattern does not automatically get fuzzier just because it has been handed along many times. Relay and fatigue are two different ideas. So why do we not receive bright, crisp light from every distant source forever? Because in the real universe the path is not a perfectly protected corridor. It is full of other structures and motions that can change what happens to the pattern when it arrives. Matter, tension valleys, and background noise all act as decision points that quietly rewrite the destination of the relay. Sometimes the tap is caught by an atom and turned into heat or chemistry. The pattern stops being a free beam and becomes extra jiggling inside a material. Sometimes an extreme field forces a light filament to bite its own tail and lock into a loop, turning the traveling pattern into a particle ring that stays put. Sometimes the pattern is shredded and redistributed into a messy bath of tiny, uncorrelated jiggles that we just call noise or background. In every case, the energy is still there and the local rule for how the sea can move is still sharp. What was lost is the clean, continuous story. This is one specific strand of light traveling along that path. You can picture it like a melody in a crowded city. A clear tune starts on one street corner. As long as each group of people passes on the melody accurately, it can spread far without losing its shape. But the city is noisy. Some groups stop singing and turn the rhythm into dancing. Some sample a fragment and fold it into a new song. Some drown it in traffic noise. The ability to move to a beat has not disappeared from anyone's body. But your original tune has been absorbed into warmth, into other patterns, into a general buzz. Light's in this view ages in a similar way. It does not slow down from fatigue. It is simply redirected, captured, ray-coded, and eventually blended into temperature, particles, and background fluctuations. That is why we can say both that light itself does not tire in the human sense and that old light from distant regions becomes harder and harder to pick out as a distinct, trackable strand. Over cosmic time, the universe is not draining the energy sea. It is just recruiting more and more of the once free, sharp rhythms into its long-term structures and its general thermal chatter. From that angle, asking whether light gets tired is a bit like asking whether a wave gets sleepy when it breaks on a shore. The motion simply changes form and joins the rest of the ocean. Next episode we'll take this same energy sea language and ask what a gravitational wave really is, a new kind of tap, or something deeper. Tap follow, share it on New Physics, Clear Universe.